settle. Today we are starting chapter 9. Today is 9-1. It's all about inverse and joint variation. It's not a super challenging day. You just kind of have to memorize a few formulas. So let's jump right in. We're going to start by just talking about the difference between a direct and an inverse variation. I would write everything that's up there down. I'm going to write them on the sideboard so we can follow along as we go through examples. But the formulas basically depend if you have y by itself or if you have k by itself. K is just going to be some constant. It's either the constant of the direct variation or the inverse variation. Whenever k is by itself, a direct variation is a division between the x and the y. So I like to think direct means divide. Direct, divide. But that only works when k is by itself. And then for inverse, when k is by itself, x and y are being multiplied. They're in a line. So inverse, in a line, direct, divide. But that only works when k is by itself. So sometimes you're looking for k. These two formulas are more helpful. Sometimes you're looking for y. So these two are more helpful. It's good to know all the different forms. So like I said, I would definitely have this written down somewhere so we can refer back to it. I will write them over here on the sideboard. And then depending what we're looking for, we'll go back and forth between these equations. All right, here's the first example. The directions say tell whether x and y show a direct variation, an inverse variation, or neither. So in number 1, we have x and y right next to each other, and they equal some constant. That looks like inverse, right? The second inverse where k equals x times y. Very good. This is an inverse variation. All right, here's number 2. So the y is by itself, and then we have an x plus a constant. Neither. That's nothing. That's just slope-intercept form. Here's number 3. So the y is by itself, and then x is being divided by some constant. If you want to also write it like this, that might help. It's direct. All right, here's another one. Now the x is by itself. We don't really have any of those formulas or equations that I gave you. So if you want to rewrite it with the y by itself, you just multiply both sides by 3. So now it's y equals some constant times x. This is also direct. Good. Do you guys remember seeing this before? Probably in Algebra 1. 4 is direct. Yes, it is like the first one under direct where y equals k times x. So y equals some number times x. Same formula as right here, y equals some number times the x. So they're both direct. When it's a constant by itself, then it should equal the x and y divided. But yeah, this one's direct. Questions? All right, so now we're just going to concentrate on inverse variation. So you're going to be given an x and a y value. They're going to tell you it's an inverse variation. You got to kind of figure out what k is. That's going to be your first job. And then you're going to try to find the y value when x equals 4. So I would make sure you write something about how it's an inverse variation. And how we're always trying to find y when x equals 4. That's going to be very important. You'll have some in your homework where it's written like this. Make sure you're reading the directions because it tells you what to make x at the end or what to make y at the end to find the other one. So when we're trying to find k, I would use the formula for inverse variation where k is by itself. So we're looking at k equals x times y. Well, they're telling you that you should start with an x of 10 and a y of 2.
Wait, you just said x equals
That's what we want to do. So first we use the given values to write an equation that relates the x and the y. Then once we have the equation, we see what y would be if x equals 4. So it's kind of like two problems in one. The first thing you want to do is find k. And then the second thing you want to do is find the y value when the x is 4. So we know that k is 20. Now we're trying to find the y value, so now I'm going to look at the other equation for inverse where the y is by itself. So y equals, well, we just said that the k value is 20, so I'm going to put a 20 in the k spot, divided by x. So now that I know what k is, I'm trying to find the y when the x is what? 4. So now I'm going to plug a 4 in. So like I said, it's kind of two problems in one. You use the x and the y that they give you on the problem to find the k. You write the equation y equals 20 divided by x. And then you're using the value given in the directions for x to find the y. So y is 5. So kind of two parts here.
Do we write it back in inverse equation?
What?
Is the answer 20 equals 4 times 5?
No, the answer, so you're just trying to find y equals 5, and then you're trying to find the k. So k equals 20. It wants you to write an equation that relates the x and the y. So I would actually write y equals 20 divided by x. But we plugged a 4 in for the x. And then y equals 5 as part of the answer too. Questions? We'll do a few more of these. Alright, so you notice the same directions. We just are starting with a different x and y now. But we're still trying to find what y would be at the end when x is 4. And it's still an inverse, so I want to start with the equation that has the k by itself. So I'll start with this guy. Plug in your x for x, your y for y. So what is k? -9. So we're going to use that given value to write an equation that relates the x and the y. So this is your first answer. Y equals -9 over x. That's the equation that relates the x and the y for this particular k value. Any questions so far? I'll give you all a second to catch up. Alright, now you're just trying to find y when x is 4. So replace that x with a 4. You can't simplify that, so y just equals -9/4. What are your questions? All right, same directions, new numbers. All right, so we want to start by finding k. So I'm going to use the equation where k is by itself for inverse. So k equals x times y. I want to look at when x is 2 and y is 8. So that would make my k value a 16. So when k is 16, this is how x and y relate to one another. So y equals 16 divided by x. So that's your first answer. You just did this part. Use the given values to write an equation relating x and y. Now you want to find the y value when x is 4, so just plug a 4 into that equation. And of course y is also 4. What are your questions on this? We're going to look at one more type. All right, here's the third type of variation. We're going to look at joint variation. Just like the other two that we looked at, there are two forms you could think of this in, whether you're trying to find z or whether you're trying to find k. So I would add these to the list. I'll add them to our list on the board as well. And then we'll do a few problems on this, and then you get your homework. So now that we're looking at joint variation with three variables, when the z is by itself, it's your k, which is your constant, times the xy. Or if you're solving for that constant k, it'll be z over xy, or z divided by x times y. Any questions on these? All right, so in this setup, we're looking at a joint variation, so we're going to use those equations that we just wrote down. They're going to give you an x, a y, and a z value. We're going to use the given values to find an equation that relates these variables. Then we're going to find z when x is 2 and y is 8. So it's just like the last setup. Basically, your first goal is to find k, and then your second goal is to find the z value when you change the x to a 2 and the y to an 8. So we're going to start with that equation where k is by itself. So k equals z divided by x times y, and then you're just going to plug in what you know from that problem. So I'm going to change the z to a 24. I'm going to change the x to a 4. I'm going to change the y to a 3. And then you just simplify from there. So it's going to be 24 divided by 12. So my k value here is 2. Now that I'm looking for z, I'm going to change to the other equation for joint variation where the z is by itself. It'll just make things a little easier on me. Instead of writing k, though, I'm going to write 2 because I just figured out that k is 2. And remember, we're looking for z in this particular case now. So I'm going to change the x to a 2 and the y to an 8, and I'm going to figure out what z would be. So z is 32. Questions? All right, here's the next one. So same directions. We're just changing the starting x, y, and z value, which will change the k value. So we want to start with that equation where k is by itself. So I'm going to start with this guy. I'm going to use the x, y, and z that were given in this particular problem. So I changed the z to a 144, change the x to an 8, change the y to a negative 54. Now you can either use your calculator to simplify this, or you can simplify as you go. So I simplified as I went, so just start simplifying the fraction. So 8 goes into 144 18 times, so I simplified those. And then 18 goes into negative 54 3 times, so I simplified those. And I'm ending up with a k of negative 1/3. You can do it that way, or you can just hit 144 ABC 8 times negative 54, enter, and it should give you the same thing. Any questions? All right, so once we find the k value, I'm going to change equations to the one where z is by itself since I'm looking for the z. So z relates to x and y in this manner. Z equals negative 1/3 times xy. Then you go back to the directions, change the x to the 2, the y to an 8, and you find the z in this case. There is your z. Z is negative 16 over 3. Questions? Here's another one for you, same basic setup. So I'm going to find k first. So I plug in 1 for x, 1/8 for y, and 4 for z. This is another one you can just simplify in the calculator, coming up with a k value of 32. Now you go to the other joint equation where the z's by itself. You'll change the k to the 32, and then you go back to the directions for the x and y. So I'm going to change x to 2, y to an 8. Find your z. Z is a big one in this one, 512. Any questions on this? This isn't too challenging. The main thing is to just figure out if you're talking about joint, direct, or inverse, and then if you're solving for that constant, or if you're solving for y, or if you're solving for z. So just, like I said, look back to the list of those equations. That'll help you get going. Any questions? Here's your homework. It's the first homework on your green sheet. If you didn't get a green sheet, you can come grab one. I have extra copies. It's just the odds, so they should be in the back of the book. Let me know if you have any questions.